Binomial series can be used to estimate the value of a function. The more terms of the series we use, the closer the approximate value is to the actual value. Here, we are asked to estimate the square root of 1.25 using the fifth order Maclaurin polynomial p sub 5 of x. It is known that the binomial series for the square root of 1 plus x is 1 plus the sum from n equals 1 to infinity of negative 1 to the power of n plus 1 over n factorial times the quantity 1 times 3 times 5 and so on until 2 times n minus 3 all over 2 to the power of n. We can use this to get the fifth order Maclaurin polynomial. This is 1 plus 1 half times x minus 1/8 times x squared plus 1/16 times x cubed minus 5 over 128 times x to the fourth plus 7 over 256 times x to the fifth. Let's now use the fifth order Maclaurin polynomial equation to estimate the square root of 1.25. Notice that our polynomial equation was found using the binomial series for the square root of 1 plus x, so we need to rewrite the square root of 1.25 to be in that form. This gives us the square root of 1.25 equals the square root of 1 plus 0.25. Now, this gives us that x is equal to 0.25, so we can substitute 0.25 in for x in the fifth order Maclaurin polynomial equation. So this is approximately equal to 1 plus 1 half times 0.25 minus 1/8 times 0.25 squared plus 1/16 times 0.25 cubed minus 5 over 128 times 0.25 to the fourth plus 7 over 256 times 0.25 to the fifth. After doing the calculations, this is approximately equal to 1.12. So our estimated value for the square root of 1.25 using the fifth order Maclaurin polynomial is 1.12.